afternoon, everyone. I'm Uma Maheshwari, Assistant Professor, Department of Electronics and Communication Engineering. In this video lecture series, I'm going to explain about a frequency shift keying. Frequency shift keying is nothing but it allows the transmission by changing the frequency of the carrier wave according to the digital modulating signal, which is called as a frequency shift keying. It is the most straightforward and efficient digital signal transmission scheme. We call it as a binary frequency shift keying. Here the frequency of the carrier wave changes between the discrete binary values of the modulating signal. Thus the frequency of the carrier shows variation according to the binary message signal. In FSK, the carrier is modulated in such a way that the high frequency signal is achieved for high level, that is 1 for binary input data. Similarly, the low frequency signal is obtained in case of a low level, that is 0, the message signal. Here we'll see about the FSK generation. As we seen that the system consists of two oscillators that generate high and low frequency signals separately. The binary message signal is provided to the transmitter circuitry. The carrier wave from the two oscillators and the binary modulating signal operates as the switch. In the case when the modulating bit is high, that is 1, the switch gets closed, forming a path. Then the frequency wave to get transmitted will get a oscillator 1. Thus a high frequency signal is achieved in case of bit 1 of the message signal. As against when the input bit is level low, the switch now gets closed in a manner from the path for the low frequency carrier to get transmitted. This low frequency carrier is generated by the oscillator 2. Hence, it is clear that the low frequency signal is achieved in case of a low data bit of the modulating signal. Thus, the higher low frequency signal is selected according to the digital modulation scheme. Thus, FSK modulated wave is transmitted and achieved at the output. This is the detection of frequency shift keying, where we'll be having a coherent detection and a non-coherent detection. In coherent detection, we'll be having a correlator 1 and correlator 2, and it is being given to the decision device, and finally will achieve the binary data. Yes, the output of the correlator is being fed to the decision device, where this decision device generates the binary signal, which is the original modulating signal. So the binary phase shift keying waveform is fed to the mixture along with the two separate carriers that are accurately synchronized with the carrier waves at the transmitting end. The output generated by the mixture is then fed to the integrator. So the output of the two separate integrators is then compared by the decision making device. When the output of the integrator 1 is more than the output of the integrator 2, then the frequency of the carrier associated with the correlator 1 generates the bit symbol. So let us assume conversely that is a low frequency carrier wave, then symbol 0 is being transmitted at the output. In non-coherent detection, we'll be having an envelope detector in case of, instead of integrator, we'll be having here the envelope detector. So the outputs of those two envelope detectors are being given to the comparator and will finally achieve the binary signal. Where bandpass filter is used here in order to tune two different frequencies, and it is being fed to the envelope detector, which generates output according to the signal which is used by the filter. Then a decision making device here compares the output of the two envelope detector. When the output of detector 1 exceeds detector 2, then logic 1 is obtained. When the output of the detector 1 is decreases by detector 2, then 0 logic is obtained at the output. The process of non-coherent detection of the FSK signal is somewhat more than the coherent detection process. Thus, the original bit stream is obtained here, which is being generated by the detector. The main advantages of FSK are it provides better noise immunity, and the signal transmission through this FSK is quite simple. Then it is used for long distance transmission. Then the bit error rate performance is better when compared to the amplitude shift keying. The main disadvantage is it utilizes more bandwidth as compared to ASK and PSK. So bandwidth is not efficient here. Then the detection of the signal at the receiver is somewhat complex. So the main applications is the technique is used in the high frequency data transmission system extensively, which is used in the low speed modems. Assessment questions: what is mean by FSK, what is mean by the difference between the coherent and the non-coherent detection, and the applications of it. Thank you.